Welcome to section 2.2. In this video, we're going to take a look at solving some linear equations that require a couple more steps, and as well as a couple other things. But first, before we get into that, let's talk about a couple things. So we have to know what an expression is. And an expression in math is anything that's not an equation. So an expression defined is mathematical operations that are not equations. So anything like 3 plus 1, that's an expression. Square root of 4 on its own is an expression. 3x plus 2, that's an expression. And a term is a part of an expression that is separated by a sum or difference. Or in other words, a term is a part of the expression that is separated by addition or subtraction. So looking at these expressions that we have here, 3 would be a term and 1 would be a term in this expression. And the square root of 4 is just on its own. So the square root of 4 is the only term in the expression. But this expression here, 3x plus 2, this expression has two terms. 3x is a term and 2 is a term in that expression. And then also within equations, you also have something that's called like terms. Now terms in an algebraic expression that have the same variable raised to the same power or are constants. So like terms are anything that have the same variables to the same powers. That would be like terms. So let's see what that would look like. So in an algebraic equation, let's say we had 3x plus 2 equals 4x plus 3. So let's figure out what our like terms would be. Well, 3x and 4x, those are like terms because they have the same variable x and they're both to the same power. And then as for the 2 and 3, those are also like terms. The 2 and the 3 are like terms. But one thing to keep in mind is that the 2 and 3 are only like terms with each other. So 4x and 2, they are not like terms. So this idea of like terms becomes very important into the kinds of linear equations that we're going to be solving in this section, because you can combine like terms in algebra. And this is how we're going to solve all these kinds of linear equations. So to just to make sure that we understand what a like term is, I'm going to write an example here, and then I am going to have you pause the video, work through it on your own, identify what the like terms are, and then we're going to work through it just to double check that you understand, because it's very important to understand what like terms are, because you're going to need to be able to define what like terms are in order to solve these kinds of equations that we're going to be solving in this section. So let's say we had the equation 2 plus 4x equals negative x minus 3. Pause the video and see if you can identify what the like terms are. And assuming you have identified your like terms, let's work through it. Well, I see a 4x here. And then on the other side of the equation, I see a negative x. So the 4x and the negative x are like terms. Now that 2 and negative 3, they're both constants. They're both numbers. So those are also like terms. I can combine those. Alrighty. So now let's dive into our first type of example. So let's say we have the linear equation 8x plus 3 equals 7 plus 4. Well, step 1, let's identify our like terms. So I have an 8x here, and I don't see at any other point in this equation there's no other x, so 8x is just on its own. But I do see a plus 3, a 7, and a plus 4. So all those are like terms, meaning we can combine everything that's underlined in green. So what I'm going to first do is I'm going to simplify this side of the equation by doing 7 plus 4. So on the left-hand side, we're going to have 8x plus 3 equals 7 plus 4, that's 11. And now, this looks very familiar to what we were solving in the first section of this notes. So we're going to solve it as we have seen. So I'm going to first start by subtracting 3 on both sides. Those 3's are going to cancel. We're going to get 8x equals 11 minus 3. It's going to be 8. And then I'm just going to move this up here. We have 8x equals 8. Now to solve for x, this 8 is being multiplied by x, so I'm going to divide 8 on both sides to get x alone. We're going to get x equals 8 divided by 8. That's 1. That's your final answer. Looking at example number 2, I encourage you to pause the video and try this one on your own. Now let's work through it together. So remember, our first step is to identify your like terms. So we have a 7z here, and then we also have a negative 3z here. And then we have a plus 2 and an 8. So looking at this equation, what I'm going to do first is I'm going to combine the 7z and negative 3z together. So we're going to have to do 7 minus 3z. I'm going to write this all out so that way we can see what I'm doing. So we're going to do 7 minus 3z first. So I'm going to put that in parentheses so we can clearly see what I'm doing. And I'm going to bring that plus 2 here and set that equal to 8. Well, 7 minus 3, that's just 4. So we're going to get 4z plus 2 equals 8. And now this looks like any other equation that we've seen on the first section. So we're going to do 4z plus 2 equals 8. So we're going to subtract 2 on both sides. We're going to get 4z equals 8 minus 2 is 6. And then, last but not least, we're going to divide by 4 on both sides to get z on its own because it's being multiplied by z. So this z becomes 6/4. Now recognize, this is our answer, but we can simplify this fraction. 6/4, 6 and 4 are both divisible by 2. So I can reduce this if I wanted to say z equals 3/2. And that's your final answer. Looking at example number 3, we have 7 minus 4y equals 3 plus 2y. So this one's a little bit different because up here on these examples, our like terms were on one side of the equation. But notice here we have a negative 4y. We don't have any other y's on this side of the equation, but we do have a y term on the opposite side of the equation. So I encourage you to pause the video and see if you can work through this one on your own. Use the same logic that we've used before. You can only combine like terms. See if you can work through it. And assuming you have given it a go, let's work through it. So because I see variables, the same variables or like terms on both sides of the equation, whenever you see the same variables on both sides of the equation, you should automatically think to yourself, okay, I need to get these variables on one side of the equation. That's your first step. So looking at this, what I would do personally is I would add 4y on both sides of this equation. Now, when you did this on your own, if you subtracted 2y on both sides of the equation, that's also correct. You can do either or. You can add 4y or you can subtract 2y on both sides, as long as you get y on one side of the equation. But the reasoning as to why I specifically added 4y on both sides is because when you add 4y, you're dealing with a positive value here because 2y plus 4y is 6y. But if you went the other route and you subtracted 2y on both sides, you get negative 4 minus 2, and you'd have a negative 6y. So me personally, I did this because I avoid negative numbers if I can. So that's one thing to keep in mind, is that sometimes to make your life easier, if you can, avoid negative numbers and only have positive numbers. So that's why I did that specifically. But subtracting 2y on both sides is also just as logical. So we have 7 equals 3 plus 2y plus 4y, that's 6y. And now we solve this like any other equation we've seen before. So we're going to first start off by subtracting 3 on both sides. I'm going to bring this up here. Give you a little messy here. Separate this. So we have these 3's cancel. 7 minus 3, that's 4. We get 4 equals 6y. And then to get y on its own, we're going to divide by 6 on both sides because 6 is being multiplied by y. So you get y equals 4 over 6. Now 4 over 6 can be simplified because they're both divisible by 2. So you get y equals 4 divided by 2, that's 2. 6 divided by 2 is 3. So y equals 2/3. Alrighty. So now that we have a general idea of what it means to, combine like terms and what happens when we do combine them and the variables cancel out with one another, and sometimes when this happens, when we combine like terms, our variables can completely cancel out. And you're left with an equation of something like 3 equals 3, or you can end up with something like 2 equals 1. Now, the answer to this and how we go about this is something I like to call special solutions. So when you're solving a linear equation and you obtain a true statement, like 7 equals 7, that means that we have all real solutions. Now, on the other hand, if you're solving a linear equation and the variables cancel out with one another and you get a false statement, like 4 equals 1, that means that there is no solution to that linear equation. So let's go through a couple examples to see what this looks like in action. All right. For example, number 1, I encourage you to pause the video and work through it just like we did in example 3 over here. It's the same process. And assuming you have worked through it, let's go through it together. So we have 8 plus 3x equals 4 plus 3x. Well, 3x, that's our like terms. We also have like terms 8 and 4. But we need to get the variables to one side of the equation. So I'm just going to subtract 3x on both sides. The 3x here cancels. Positive 3x minus 3x cancels. Positive 3x minus 3x, that also cancels. So we're left with 8 equals 4. Well, 8 isn't equal to 4, right? So because this is a false statement, there is no real solutions to this equation. And that's all. That's your answer. Sometimes you might see this symbol here, a circle with a dash drawn through it. This symbol also means no real solutions as well. So you can write either or, and both of these answers mean the same thing. Looking at example number 2, we have 4w minus 4 equals 7w minus 4 minus 3w. So we have a little bit more going on in this equation, but let's work through it. So let's first identify our like terms. We have 4w, 7w, and negative 3w. we also have -4 and -4. So let's first start off by combining the like terms on this side of the equation. So we're going to get 4w minus 4 equals 7w minus 3. Well, that's going to become 4w minus 4. And now let's subtract 4w on both sides to get w on one side of the equation. The w's here cancel, and the w's here also cancel out. So we're left with -4 equals -4. Well, that's a true statement, right? -4 does equal -4. They're the same value. So this is a true equation, which means you have all real solutions. Oops. Solutions. That's your answer. And symbolically, you can also write this if you want. An R with like a line drawn through it like this. This also means all real solutions symbolically. So before I end this video, I just want to talk real quick about what exactly does this mean. What does no real solutions mean? And what does all real solutions mean? Because that's a very important question to understand as we progress throughout algebra. So no real solutions, what that means is that you cannot, there's not a value that exists for x in this equation that you can plug in that'll make this equation true. There's no value that you can plug in where you can get both sides equal to each other. It's impossible. That's what this means. There's no solutions. You can't find it. There's no singular value that you can find. For something like this, all real solutions, that means you can plug in any value you want. It can be any value that you know of. It can be something like extreme, like 100 billion, or it can be something as like little as like 0 or 1 or 2. Regardless of the value you plug in for w, you will always get a true statement, a true equation. Both sides of this equation will always equal each other regardless of the value you plug in. That's what all real solutions and no real solutions mean.